This is the Quiz 3 video lecture. This quiz video is designed to teach and train students to manipulate the world of geographic coordinate systems and projections in Esri ArcMap. I've got my Quiz 3 blank all saved. I've done some of the preliminary steps, so that's what we're looking at here. It is imperative that these skills are learned now, thus the complexity of these directions and the video. In this quiz, we are using Universal Transverse Mercator UTM Projection named NAD, North American Datum, 1983, specifically designed for our area of the Earth, 10N. It's known as NAD 1983 UTM Zone 10N. To line up all of our data, because our focus is on Tacoma and Washington, and we're using the same UTM projection NAD 1983 designed for our area of the Earth. We'll be using the same one in Lab 3 for symmetry and knowledge transfer. It's highly suggested that students download the Quiz 3 video lecture instructions or steps so that you may follow along. If you get behind, simply pause, rewind, and rewatch the video. This is your guideline to completing the Quiz 3 video lecture quiz in preparation for Lab 3. You may want to create a Microsoft Word write-up in which you enter the answers to the questions digitally, or you may print these directions that are available in Canvas and record your answers with a pen and pencil on the hard copy. At the very least, somehow record your answers to the questions 1 through 82 in preparation for the Quiz 3 video lecture quiz. This may be completed on a phone or tablet or virtually any device that can access the internet. No access to ArcMap is required. Simply follow along and write your answers down or record them in a Word document. The instructions or the beginning portion of this is just setup, but I wanted to review it. I've already taken care of it, so I won't be demonstrating it. But I've set up my Quiz 3 directory in my directory over here. So I've got my data moved to the data folder from the raw data. I've already downloaded it. There's nothing in the raw data. I've also gone to Map Document Properties and completed these items so that those are taken care of. In Geoprocessing Options, I've made sure that background processing is not on, and in my environments, I've changed the workspace to my data K3 folder. Soon we'll be setting the output coordinates here on future labs. Now that I've got my entire directory set up, I'm going to move on to step 2. In this step, I'm going to sift through the data one by one and determine the current coordinate system, geographic coordinate system, projection, datum, and spheroid of each layer. Note that some may not have all of these items due to the nature of the data. Because we have chosen to use UTM Projection NAD 1983 10N, it is imperative that we know the details or the metadata of our data prior to adding it to the map. We must fix any data that does not currently use our desired coordinate system in projection, which again is projected coordinate system NAD 1983 UTM Zone 10N. For some of the answers, the answer will be unknown, none, no coordinate system, etc. This is an important item. There is a hard and fast rule for both types of coordinate systems, geographic coordinate systems and projected coordinate systems, when working to line up your data. It should be noted here that all of your data must line up. That is, be in the same coordinate system, whether that be geographic coordinate system or projected. Whatever you've chosen or been told to use, if data has some sort of spatial reference, any spatial reference, you need only project the data unless it is in the spatial reference that you have chosen or been assigned, in which case you need not do anything. If the data has no spatial reference, also known as unknown or undefined, you must first define the projection and then perhaps project, depending on the final choice of the coordinate system. Usually, especially in GIS 311, 312, and 414 at the University of Washington, Tacoma, we use projected coordinate systems because we are designing paper maps. Thus, there is an easy formula. Assume, for example, we're using XYZ projected coordinate system. Ask yourself these questions to decide how to work with your data. Does the data I'm using have any spatial reference? If yes, does the system have the XYZ projected coordinate system already? If yes, nothing is required. The data is ready to use. If no, the data must be projected to the XYZ projected coordinate system. If the answer is no to the original question, does the data I'm using have any spatial reference? You must first define the projection, which is a completely different tool. 99.9% of the time in GIS 311, 312, and 414, we will define the projection to Geographic, North America, USA and Territories, NAD 1983, and then project it to the chosen projected system. And in this case, in the example, XYZ projected coordinate system. Save this information. You will need it. The difference between define projection and project are that define projection merely changes the metadata describing the projection coordinate system of the data. The metadata that this tool creates is a PRJ, TFW, and .AUX within your existing data. Remember, we use define projection when an unknown spatial reference warning appears in ArcMap. A key element. You must know what projection the data is in to run this tool. And for 311, 312, and 414, it's almost guaranteed you will be safe using define projection tool and then geographic coordinate systems, North America, USA and Territories, NAD 1983. Alternately than the define projection tool, the project tool creates an entirely new data set and usually adds it or prompts you to add it as a new layer to your map. So to refresh, a define projection does not create a new layer, it just adds additional files to your layer. And the project tool creates a new layer. Normally we'll end up with a projected layer because we're creating paper maps. The first step of this process involves determining what we have in terms of data. In the directions, if you're following along, we're going to click on the properties of our currently renamed data frame, coordinate system tab. So I right click, properties, coordinate system. The current coordinate system is no coordinate system. What you are looking at now is the projection on the fly. ArcMap changes the projection seemingly willy-nilly, but it isn't. And there's a link listed in the directions to help you figure out what we're talking about when we say projection on the fly. We're going to get started with checking our data. We're going to use City of Tacoma to answer the questions. What is the current coordinate system of the City of Tacoma? I right click, properties, current coordinate system. I'm on the XY coordinate system. It is NAD 1983 State Plane Washington South FIPS, which is Federal Industry Processing Standard, 4602 feet. So that is the current coordinate system. If I scroll down further, I can find the geographic coordinate system, which is GCS North American 1983. To find the projection, I look still in the same window, and that is Lambert Conformal Conic. The datum is also listed, D, North America, North American, 1983. What is a datum? If you look at the directions, there are a couple links to help you figure out what is a datum. You could also just Google what is a datum. And then the spheroid. The spheroid being used is GRS 1980. And that was number 6 on the directions. What is a spheroid? There's a link in the directions to help you figure out what a spheroid is. You may also Google what is a spheroid. Moving on in the directions. Given that we plan to use Universal Transverse Mercator Projection, NAD 1983, North American Datum 1983, for our area of the Earth, 10N, will we be required to alter the spatial data properties of this data? Yes or no? If yes, what must we do? Define and project, or just project? So looking at this, it does have spatial reference of data. So therefore, if I go to my question, does the data have any spatial reference? The answer is yes. In that case, I need only project it if this is not what I'd like to use. Because I'm going to use NAD 1983 UTM Zone 10N, in this case I must just project because this is not correct. Moving on. Use miscellaneous shapes for the next questions. What is the current coordinate system? Unknown. Therefore, the geographic coordinate system is also unknown. There is no projection, there is no datum, there is no spheroid. Question number 3. Given that we plan to use UTM Zone 10N, will we be required to alter the spatial properties of this data? Well, the answer is yes, because it doesn't have any spatial properties and it will not line up at all. So what must we do? We go back to our question to decide, and is there any spatial data properties in the data set? In this case, no. Therefore, we must define the data and then we must project. So the answer is yes, we'll have to alter it and then we must define and project. Moving on to item 14. Use the PhD dataset to answer the question below. The current coordinate system. Well, right click, properties, there is no coordinate system because this is tabular data. It's a database, or it looks a lot like a spreadsheet. So there is no coordinate system, there is no geographic coordinate system, there's no projection, no datum, and no spheroid. Moving on to number 19, will we be required to alter the spatial properties of this data? The answer is no, because it is not spatial data. Moving on to the next item. Using tagged shapes, answer the questions below. Right click on tagged shapes, properties, the current coordinate system, that is the top line. That is the current coordinate system. The geographic coordinate system is also listed. And it's a little bit different than the last one. It's similar but different. The projection is also listed here. Lambert conformal conic. The datum, D, North American, 1983, Harn. And then the spheroid, GRS, 1980. Question number 25. Given that we plan to use NAD 1983 UTM Zone 10N, will we be required to alter the spatial properties of this data? The answer is yes, because this is not NAD 1983 UTM Zone 10N. And what must we do? There is a spatial reference, so we must just project. Moving along to Tacoma proper SP PH. Properties. Current coordinate system, listed here. Geographic coordinate system, GCS North American 1983, Harn. Projection, Lambert conformal conic. Datum, D North American 1983 Harn. And the spheroid is again GRS 1980. The same question pops up. Given that we plan to use NAD 1983 UTM Zone 10N, will we be required to alter the spatial properties of this data? The answer is yes, and by now it should be clear that we only need to project because there is a spatial reference. Last but not least, we'll move on to Washington, the current coordinate system of Washington. We'll right-click, Properties, GCS North American 1983. That is the current coordinate system, the top line, as shown here. The next question, the geographic coordinate system, is kind of a trick question, but it's written right into the answer. The geographic coordinate system, GCS, is North American 1983. So GCS North American 1983. There is no projection, question 34, because this is not a projected layer. This is based on just geographic coordinate system. Therefore, there is no datum and there is no spheroid. Given that we plan to use UTM 1983, NAD 1983 UTM Zone 10N, will we be required to alter the spatial properties of this data? The answer is yes. And what must we do? We must simply project because there is spatial data. The only time we would define projection would be when there is no spatial data. I have completed step 2. While we didn't do hardly anything to our map except look, I'm still going to save my map as step 2.